Hello and welcome to podcast.init, the podcast about Python and the people who make it great. When you're ready to launch your next app or want to try a project you hear about on the show, you'll need somewhere to deploy it, so take a look at our friends over at Linode. With 200 gigabit private networking, node balancers, a 40 gigabit public network, fast object storage, and a brand new managed Kubernetes platform, all controlled by a convenient API, you've got everything you need to scale up. And for your tasks that need fast computation, such as training machine learning models or running your CI and CD pipelines, they've got dedicated CPU and GPU instances. Go to pythonpodcast.com/linode, that's Linode today to get a $20 credit and launch a new server in under a minute. And don't forget to thank them for their continued support of this show. You listen to this show to learn and stay up to date with the ways that Python is being used, including the latest in machine learning and data analysis. For even more opportunities to meet, listen, and learn from your peers, you don't want to miss out on great conferences. And now the events are coming to you with no travel necessary. We have partnered with organizations such as ODSC and Data Council. Upcoming events include the Observe 2020 Virtual Conference on April 6th and ODSC East, which has also gone virtual starting April 16th. Go to pythonpodcast.com/conferences to learn more about these and other events and take advantage of our partners' discounts to save money when you register today. Your host as usual is Tobias Macey, and today I'm interviewing Matthew Honnibal about the Thinc and Prodigy tools and an update on SpaCy. So Matthew, can you start by introducing yourself?
Hi Tobias, thanks for having me again. I'm the creator of the SpaCy Natural Language Processing Library. It's a popular tool for working with text in Python. So it's often used for information extraction projects and also data science projects to understand text at scale. And I'm the co-founder of our company Explosion AI. So we also make an annotation tool called Prodigy. And we've recently updated and released a machine learning component of SpaCy as its own library, Thinc, as well, which is another thing that I'm excited to talk to you about today.
And you were actually on the podcast about 3.5 years ago to talk about SpaCy, so I'm definitely excited to hear about where things have gone since then. But before that, can you share how you first got introduced to Python?
Sure. So, like a lot of people, I came to problems that I wanted to solve with programming before I came to decisions about languages or those sorts of technical things. So basically, I started out in linguistics and I was doing research, and I wanted to process volumes of text to answer questions about grammar or to basically work with the linguistic theory that I was working with. And so then it just sort of started from there, and I started writing small scripts and everything. And I actually first started out with Perl, but I quite quickly switched across to Python. So this was in around 2004, 2005. And since then, I've really worked with Python for pretty much my whole career, except for eventually I realized that I wanted to write programs that were faster and programs in particular which were more memory efficient, so that I could write, basically concise data structures that would work well with the problems that I was working with. And so then I started working with Python, and I've found that a really good compromise for that, because for some problems it just is a lot easier if you can sit down and plan out the memory ahead of time and sort of reason about how much you can hold in memory. So that's how, and that was all very much informed how SpaCy was written, because the library is really implemented in Python rather than in Python directly.
And at the time when we spoke, the natural language toolkit was still sort of the de facto standard for anybody who wanted to do any sort of natural language processing. But these days, most of the times when I see references to people doing any sort of NLP, SpaCy has become the more prominent library for that. So I'm curious what your sense of that has been as the creator and maintainer of SpaCy, how things have progressed over the past few years in terms of the level of popularity and adoption for your library.
So NLTK is still an extremely popular and useful library, and they really do different things. So I would, never want to say that, there's only one way to do it and that, the other tools are like deprecated or something. Like, there's still a lot of functionality in NLTK, and there's use cases where people find its approach of not having to initialize as much, like, load a large model into place, and, it's basically got all of these utility functions. So it's still certainly a very popular tool. But I've been pleased to see that a lot of people have been finding SpaCy useful, and especially for models that are pre-trained and sort of pre-trained processing pipelines, and also data structures for working with different annotations. So one thing that I think SpaCy is quite good at is if you've got annotations that are like entities in text, and you want to do things like get relations between them, or you want to find their parts of speech, or you want to retokenize a text, the object-oriented interface in SpaCy makes it quite easy to interact with those annotation layers together. And so people are finding that quite useful. Also processing pipelines. So being able to string together rule-based matching with entity recognition, and then apply some other rules on top, and then get out the document at the end is something that I think SpaCy is quite strong at as well. And so that's why people are using it for these processing pipelines. And SpaCy also has a little bit more of industrial use case focus. So it's more oriented towards production use cases. And so I think there's a lot of companies who've basically been looking for a tool that has that kind of focus rather than one which is more oriented towards teaching or research.
And for the work that you're doing at Explosion, you mentioned that you founded the company around the same time that we talked, and as a follow-on from your work on SpaCy. So I'm wondering if you can give a bit of an overview of the mission for that company and highlight some of the different projects that you've been working on there.
Yeah, so when we first started out with Explosion, we did some consulting projects for 6 or 7 months. We refer to this, together with my co-founder Ines, as raising a client round. It was really a good way to basically understand what sort of problems people had with NLP and figure out what we wanted to do next. And so then the product that we ended up releasing was this annotation tool, Prodigy, and that's been going very well since, and that's been, really funding our activities in the company. So the way that we see things is that one of the needs that people have for machine learning technologies is to be able to develop them closely themselves. So around when we were founding Explosion, there were a lot of people who were thinking that AI technologies like NLP would be something that you consumed as a cloud service, and you would really have very few developers working closely with across these technologies. And our bet was different. Our bet was that this is a bit more like web development, in that to really make use of the technology effectively in projects and products, people would need to work with it closely. And there would be a lot of developers who wanted to understand how all of these technologies fit together. And so open source and sort of self-run technologies would be the way that people wanted to build their projects. And I think that that's largely true. That's largely the way that people have been working with AI, is to be using open source libraries, or, at least self-hosted technologies that they can really understand in detail. So we wanted to basically have a tech stack that fit along with that sort of viewpoint, so that people could run their projects more, basically move faster and try things out.
And so going back to SpaCy, in the last 3.5 years, there have been a lot of new innovations and shifts in direction for the study and usage of natural language, with models such as BERT and GPT-2 coming out. And I'm curious how that has influenced the direction or the implementation of SpaCy itself, and any other product developments or project updates that you think are worth noting and that have happened in that time frame.
Yeah, so that's definitely been a very exciting thing that's been happening with natural language processing. So essentially, it's all of these models give the ability to have very accurate models through language model pre-training. So a problem for natural language processing technologies has always been this problem that's broadly called the knowledge acquisition bottleneck. And that's that there's so much knowledge that's kind of in the background about language that a model that has to work with language has to understand about the world in order to get any specific application done. So let's say you want to do something, reasonably boring, like extract certain financial figures from some document. And so it's, profit and loss statements from company filings or something. All of these other words and all of these background things that the model has to sort of understand something about in order to figure out which sentences are of interest to and which sentences are providing that information. And if you have a person that you're teaching to do this, along with all of their knowledge about the world and general intelligence, they have this just knowledge of language that means that they only have to learn a little bit about the task before they can do it very accurately. Whereas if you have a model that has to see all of these words for the first time, you need an enormous number of examples to teach it this boring task. It would be like having a a new employee, and instead of just teaching them what to do, you have to teach them English as well. And that's, obviously a huge learning curve where you want to be able to import the general capability of English and just teach your task on top. And that's always been a well-identified problem for natural language processing models. And finally, over the last couple of years, we've really had a big breakthrough in how this is done. So these models basically start off learning to predict the next word or some task similar to it from large bodies of text. And they can use this knowledge to, you can start off with that knowledge and apply it to some specific task. Now, the challenge at the moment is that these models have largely been developed by research labs who have, where compute costs are completely not a consideration. And they've especially been developed to favor GPU and TPU devices. So this means that if you just run these models straight from research at the moment, they're really quite expensive to run. And so if you want to be processing large volumes of text and you want to run the processing several times because you want to keep experimenting, the costs of running those models starts to add up very quickly. You also have problems with serving them because if you've got a model that requires a GPU device, the latency for using it effectively starts to get quite significant because you need to batch up a lot of examples. So it's been very exciting to see these breakthroughs happen, but the challenge has been basically adjusting, the architectures that we have and finding the right compromise between models which are still cheap to run and models which are still low enough latency while being able to take advantage of the high accuracy from these new techniques. And these problems are constantly evolving, and there's more and more work that's coming out recently about making these models smaller and more efficient as well.
And another element of the large models that I've seen referenced is doing things like transfer learning for being able to take the existing models and then swap out a couple of the layers to be able to make it fit your specific use case. Is that something that SpaCy is used for in that context as well, or is that sort of outside of the scope?
So we have a command like SpaCy pre-train where you can, run language model pre-training even, basically from scratch. But you can also, especially with Thinc, it's quite easy to sort of plug these layers together and to take advantage of these sorts of technologies. And in SpaCy, the reason that we sort of redesigned Thinc was really to take advantage of this type of model better. So one of the challenges that, basically is introduced by the new transformer architectures and the new ways of doing machine learning, that when SpaCy was first developed, I thought carefully about what the right level of abstraction was to present to developers so that they could take advantage of natural language processing technologies which bits of complexity to shield off from them and which bits to present as like the decisions that they would be making. So the level of abstraction that was sort of most sensible when I was designing the library was to think at the component level and say, all right, well, this is a named entity recognizer and it does, this task of assigning labels to text, and then you can combine it with like a tagger, or you can combine it with, a parser, and then these are things which will analyze the text, and then you'll get back this doc object and you'll basically work with the doc object from there. Now, with the neural network technologies, and in particular with the transfer learning technologies, it's the level of abstraction that's sort of most handy for developers to work with is a little bit different, because you want to be able to take these models and basically be thinking about the tensors and thinking about, saying, all right, well, I'll feed this bit of, this word representation out into this layer, and I'll share that information with this other layer. And that's really a level that, basically developers want to be working with now, because, the knowledge of these models is pretty detailed in the community. There's a lot of people who, understand these things pretty well. And so the abstraction is different. And so this is something that we've basically wanted to adjust in the library and, make it easier to work at that sort of level while still, making sure that the library does the job that, it originally did as well, of working at the pipeline layer as well.
Another development that has happened since we last talked is the fact that you've added support for a number of other languages, whereas at the time, I believe it was only English and German. And I'm curious what you have found to be some of the most challenging aspects of building those additional models for different languages, and any challenges that you see in terms of being able to support things like symbolic languages like Japanese or Korean, or right to left languages such as Arabic.
Yeah, so in terms of supporting more languages, I would say that the two big challenges are DevOps and data. So the DevOps challenge is simply that, as we've added more languages, the operational complexity of training all of the models and the automation required to have those jobs complete well and, have pipelines for all of these things so that, reliably and with low manual effort, we can get all of those artifacts built, tested for each release. And that was something that took longer than I thought it might. The training jobs take, a fair bit of time, and then for each individual training job, you need to be able to resume it and stuff. So I tried out a number of technologies like Airflow, Luigi, and things. They ended up with, basically a setup that works well for us. But this was definitely a challenge. And, that was a thing that took a fair bit of time setting up all of these things, partly because, these DevOps tasks aren't ones which I was, had so much deep expertise in. So there was a bit of a learning curve for me there as well. And then the other one is just the data resources. So we want to make sure that for all of these languages, when we produce a model, that it's, basically useful to people and that the models don't just sort of exist for the sake of it. So that's been something that's been difficult, and especially with different corpora and not having inconsistent licensing and stuff, we want to make sure that the models that we produce are, available for commercial use for people, and also that the data is good enough that it's, something that's actually useful. So over time, one of the things that's changed since we last talked is the universal dependency corpora have gotten a lot better and gotten, pretty consistent. And so that's something that we've been able to take advantage of and produce some more of these models.
And for being able to build out these models, as you said, one of the challenges is having the appropriate corpora. And I imagine that another aspect is being able to label it effectively and find pre-labeled data sets, where I'm sure that some of the inspiration for your Prodigy tool came from. So I'm wondering if you can just talk through a bit of the motivation for creating that and describe the use cases that it enables and the workflow for somebody using it.
Yeah, so definitely questions about labeling data are, some of the problems around this. And, so we sort of, when we were doing the consulting, this was definitely something that teams were struggling with. So probably the most important thing that we thought that we could offer that was a little bit different from, or lacking in people's process was, I guess you could say it's more of an agile methodology to data labeling. So the problem of labeling data is, well, you just sort of decide what the labels should be, and then you tell somebody to apply that labeling scheme. And then the problem is just this grunt work task of getting the things done. And for some tasks, it looks a little bit like that. Some image tasks are a little bit more like that. But certainly for language, as soon as you come up with any labeling scheme and you start applying it to text, you very quickly realize that there's all these edge cases. And it's kind of edge cases all the way down. And even more importantly, you need to realize that there are ways that you can adjust the labeling scheme that will hit a better compromise between what will be useful for your model or what will be useful for your end goal, and what will be easy to annotate and what the model will be able to, annotate effectively. So, the other day we were working on a little demo of Prodigy, and we were annotating instances of like ingredients in cooking discussions. It's because we wanted to see, all right, well, there are all these like trends in what sort of foods people are using, especially for home cooks and things. So we wanted to see, all right, well, can we find some of those in the frequencies with which different ingredients are mentioned? And so this sounds, simple enough, but then you quickly realize that there's not really a clear distinction between what's an ingredient and what's a finished product, because in sometimes you might have something that, I don't know, like chicken fillets could be a ingredient in a recipe, or it could be the recipe itself. So, and there's all sorts of other examples like this where you're kind of not sure of the boundaries. And so always you're making these decisions when you're annotating any project. And that means that you have to basically take a pretty flexible view of what you're doing. And it means that you have to be able to start and stop the annotations and look at the data and have a basically integrated process. So that's really what we did with Prodigy. We made sure that it was a tool that was fully scriptable, so that you can really have control of the annotation process yourself, and you'll be able to build out different capabilities and build whatever automation you need as well. So you can drive it from Python, and if you can basically write a function in Python that generates the data, then that will be something that you can quite easily put in your little function and then have that thrown up in a web browser for you to click through, and then it'll be saved in a local database. And you can make different choices if you want to scale out. For instance, you can have the database saved to a MySQL instance instead of a local SQLite file. You can host the application in different ways. But at the core of it, as a tool for any data scientist working individually, it's a really quick way to be able to build out these experiments yourself and be able to try different things so that you don't have this stumbling block of as soon as you need some small amount of annotation, you hit a sort of process block and you have to do something different or have to go to your team and get basically apply for funding with it to throw it out to an external labeling service. Instead, it's just something that you can do flexibly yourself.
And I know that there are some other labeling tools out there. I'm curious what you saw as being some of the lacking features or capabilities in the available market that necessitated building out Prodigy as an alternative to them.
So the number one thing was really the design of it as a developer tool and a scriptable developer tool. Because when we talk to people about their experience doing annotation and using annotation tooling, almost all of them had built annotation tools in-house. And that was something that was worth thinking about. It's like, okay, so if this is a type of problem where people are very frequently motivated to write their own tools, why would that be? And, the simple answer is, well, nobody's come up with, just to write annotation tool that everybody needs. And I don't think it's quite that. I think it's that, the needs are quite flexible and people want to have control of the process because that's kind of efficient and different needs are different. So we wanted to make sure that it was something that people could really work with and that they could work with as developers. So, the scriptability and the fact that people can interact with it programmatically and have it self-hosted is something that, we really wanted to build into the design. So most of the other things are designed as web applications, and programming against a web application that you're not hosting is always going to be kind of limited. The other problem is data privacy. So the vast majority of our users really don't want to, often simply can't upload their text into some cloud service. And this makes a lot of sense to me. Like if I've got text in a platform that's private to me, I don't think that vendor or that those people should be sending that data to, some external third parties. And, since then, the regulation has also caught up with this, view that I have of how things should work. And I think that that's great. And I think that the US is catching up with this as well. And we'll have, rules that are more standardized to the way that it works in Europe too.
Another thing that I saw that was appealing about Prodigy is the fact that it supports multiple different types of data for being able to label it. So it has capabilities for text so that you can do things like named entity recognition, like you were referring to earlier, being able to say, in the example you gave, this is an ingredient versus this is a finished product. But it also has support for being able to do labeling of images and segmentation of those images to say, this is a rectangular area, this is a polygonal area, and this is the label associated with it. And then you also have support for some other data types as well. So I'm curious what you have found to be some of the challenges of building a tool that supports those different data types and some of the value that you've seen come out of it.
Yeah, so basically just trying to make the right compromises between, what people need and different use cases while still without, diffusing too much and being less useful for any particular use case. So, to be clear, I do think that there'll always be other tooling that people want to use as well. And I think that some of the worst things that computational tools or actually tools in general can do is to try to be the one-stop shop for all use cases in all situations. I think, it's important to do the job that you set out for yourself well, but a lot of people have found it useful to have this variety of capabilities in Prodigy so that you don't have to have very different workflows just because you now have an image task as opposed to a text task. We've also introduced some nice audio support recently as well, and there's Ines has had some fun building that out and getting, an interface that's helpful for that. So one of the challenges has been designing workflows for things that we don't do ourselves so often. We still don't do a lot of image work in terms of our actual projects, and we don't have as deep an expertise on them. So making sure that we, basically doing something that's helpful to people without having as close a connection to it, I think is something that we've had to, think carefully about. And then, different data sizes and stuff. So, obviously the size of the input for something like video or image or audio is quite different from text. And so we had to make some adjustments in the way that the database works and stuff to make sure that those are well accommodated.
And you mentioned too some of the challenge of being able to allocate funding for working with an external labeling service where you can have the capacity for doing your own labeling, at least on a small to medium scale. And I'm curious what you see as being a reasonable scale of data that can be handled by an individual or a small team, and at what point you think it's necessary to start working with some of these labeling services to handle more large scale or more fine-grained labeling for the data that you need to use for building your models or building your products.
Well, so I think that you definitely can get something to production with working with it basically with having just sort of ad hoc resources of yourself or your team or like maybe some interns or like some other junior people around the place. And so it depends on the tasks and it depends on how much data is needed to get the models trained, because there's no one answer for this. The different tasks have different complexities and things. So I would say that the number of examples that you need per model is dropping all the time because the transfer learning technologies are very good. So I would say that, especially now, you need less data than ever. And I would always be focused on, if you find that you're needing, hundreds of hours of annotation, then rather than just saying, well, this is our life, that's just how much we need, I would always be suggesting that you look at ways that you can redesign the models, because it may be that, something's wrong with the way that you're actually defining the problem. So I'll give you an example of this. One of the examples that I use in some of my talks is, imagine that what you wanted to do is extract information from crime reports, and you wanted to fill out this database of, who the victim's name, a perpetrator name if it's there, a location where the event happened, the event type or something. So one way of doing this is very directly, and you might say, all right, I'm going to do this as a labeling task where I label this span of text, John Smith, as victim. And then this other span of text or location can cross as, location of crime or something. And so, that's definitely a way that you will be able to train the model, but you're coupling two pieces of information. You're coupling the identification of that John Smith as a person with the fact that the event is about, well, actually you're coupling three pieces of information. The sentence is about, the event type crime, and John Smith's role in that event is the role of victim. So if you factor those three pieces of information out, you can often need far less data, because the decision of, all right, that's a person versus not a person is basically easier, and it doesn't require as much information about the whole rest of the sentence. Similarly, the information that, is this sentence about a crime or is it not about a crime? That's one bit of information that you can annotate over the whole sentence. And so if you annotate these separately and you train the models separately, you can often need far less data. And so you'll have some situations where people are finding that the model isn't converging well, and their first instinct is to either try a different architecture or to annotate more data, when by far the most best lever to pull is one which people don't really have practice pulling, because it's not one which you'll have gotten from shared tasks, or you'll have gotten from writing papers and things. And that lever is, how can I redesign the task? How can I find a different way to either need less for the application, or to just structure the models differently so that they attack different parts of the task and define things differently? How can I say, all right, well, what if I did this as a sentence labeling task rather than as labeling the words in the sentence? Would my application be able to deal with that slightly less precise piece of information? Well, if so, maybe you'll find that the model converges far faster and far better. So to answer the question about when I would actually switch to a labeling service, I think actually I would use a labeling service basically never. And the alternative, after you have it pass prototype, I would actually have people be hiring people to do the work in-house. And, they can be remote employees or people on freelance contracts, but I would always want them to be specific people that I can talk to under the supervision of the project. Because after you get past the prototyping stage, the task of the labeling data is this discrete event where you do it once, get back this batch of tasks, and then the project is kind of shut down. It'll be something that you constantly want, this feed of data and feed of examples, so that you can keep monitoring the model, keep improving it over time. And you don't want to have it as these discrete contracts where the data is going to be different each time you go back to the service, because you're getting it done by different people with different standards, potentially with different pricing. And it's, basically something that you want to have consistent control over time, because your needs will change as well. The needs of what you're going to find that, I want to adjust slightly the way that the data is annotated, because there's this problem in the application problem in the model that needs to be solved.
And the third component that we mentioned at the opening and that ties into this whole ecosystem that you're building out is the Thinc project, which you mentioned was extracted from the SpaCy project originally. I'm wondering if you can just talk a bit more about the motivation for releasing it as its own library and some of the primary problems that you're aiming to solve with it within the ecosystem of machine learning and data science.
Yeah, so SpaCy always kind of came with its own machine learning implementations. And initially, it was basically a pretty simple linear model that was optimized to work with very sparse features using the average perceptron algorithm. And so this was always, for these linear models, it was pretty common in NLP for basically everybody to implement themselves. And most other parsers would have their own linear model implementations lurking within them. So I did it the same way, and I found that basically a helpful way to keep the model efficient and working well. And then over time, as the neural network models came in, I had already been implementing neural network code right about when PyTorch came out. I was basically done with the models, and we were experimenting for SpaCy 2. So if PyTorch had come out earlier than that, before I'd basically been doing all of that work, there's probably every chance we would have just used PyTorch from the start. But one of the advantages that we saw in SpaCy 2 of sticking with our own implementation was that we could make the library a little bit smaller, because we only had to implement the models that we needed, and we didn't have to drag in this whole huge binaries from an external library. And we were able to make sure that we didn't have a dependency on a specific version of PyTorch, because we knew that the library would evolve quickly, and we wanted to make sure that people never hit a situation where they had two projects and SpaCy needed a particular range of versions of PyTorch, and then their other code needed a different range of versions of PyTorch, and so that they had this lock. So that was always something that we were conscious of as well. So over time, we have kept using our own implementations, but as I mentioned, more and more people have wanted to interact with the machine learning layer, underneath. People need to be able to define their own models and bring their own models into, SpaCy and Prodigy. And so what we decided to do, rather than standardizing on PyTorch directly, was to sort of adapt Thinc into a library where you that could sit as a wrapper around different machine learning solutions underneath. So in addition to Thinc's own implementations of things, you can use it as a just sort of interface layer above PyTorch, so that you can really easily define any PyTorch model that you want, and then Thinc is just the interface layer that interacts with it in SpaCy. So that was what we sort of set out to do. And the way that we approached that was to really think about what's the sort of lightest weight or most minimal interface that is necessary for this type of deep learning library. And we ended up with a functional programming inspired design that features a very minimal interface of a single model class. And the actual work of the layers is done in function definitions. And instead of bringing in a definition of some sort of autograd mechanism or type-based differentiation like you have in PyTorch, there's just this convention of callback mechanisms, and then you have different relationships between layers, like say a feed-forward relationship or concatenation or subtraction or something, is all handled by higher order functions. So we ended up with a design that's really quite lightweight and minimal, and the library itself is quite small and easy to read. And this means that you can really bring any model that you want from another library, but whether PyTorch, MXNet, TensorFlow, and you can plug them into SpaCy and plug them into PyTorch. We also built out a few other user interface features that we felt would be very helpful. And the main one is that I think is kind of underrated as a problem in machine learning is the problem of configuration. So we always found in SpaCy that there's this problem of how to pass configuration through a tree of objects. So one way to do it is that you pass into some component a whole tree of configuration that defines for that model and then maybe components of the model, etc. So you have this blob of configuration you pass top down into something. But this means that as soon as that component has a pluggable sub pieces, it can never know which what features or what configuration options its individual parts will need. So if I want to say configure a parser or a tagger, and I want to give flexibility of the model of that, or allow people to change individual pieces of that model, then I have to pass all of this opaque blob of configuration forward. And then those functions that are being configured probably have defaults and things. So you end up with this problem of different defaults being set, and you can very often have problems where you think that you've overridden the default and you haven't. So instead of passing the configuration top down like that, we have a way of defining the configuration bottom up through the config file and letting the tree of objects be defined and sort of brought in from that. And we've found that really helpful in keeping the code clean and helping to manage this problem of defaults. And then finally, we've got typing. So Python 3 has type declarations, and we've really made good use of these in Thinc. So it's the first time I've really seen good really full support for NumPy arrays and things in, a PyData ecosystem. We have, so that you can get static type errors for something like indexing an array in a way that's invalid because it's, a three-dimensional array and you've used too many indices or something. So yeah, I think that's an exciting feature that will be very helpful to people as well.
And one of the things that I thought about as I was looking at Thinc is because of the fact that it acts as a high-level wrapper for multiple different frameworks for doing deep learning, it puts it in some sense in the same space as the Keras project. And I'm curious what your sense of the comparison is for being the comparison of Thinc versus Keras in terms of acting as that wrapping layer.
Yeah, so I really found the functional programming style in Keras very interesting when I first saw it, and it was definitely something that helped inspire the approach that we took in Thinc. But over time, the sort of focus of Keras has shifted a little bit, and it is really part of TensorFlow these days, and it's really the way that basically it's sort of the main interface into TensorFlow that people use, and it's really a high level API for TensorFlow that's quite coupled into the TensorFlow ecosystem. So I would say that the focus is a little bit different with Thinc, and we've also benefited from coming into it a little bit later and being able to come up with a design that's a little bit tighter and that will be able to maintain a little bit more consistency over time, so that we really hope that we will not have to make breaking changes over time, and that we are able to basically keep the design quite concise and coherent. So I would say that the use case is a little bit different, and that Keras is not so much a wrapper around different things as much as just a key part of TensorFlow specifically.
And then because of the fact that Thinc also acts as its own framework for building these neural nets and doing deep learning, I'm curious what you have found to be the strategy that you use in terms of determining when to do something entirely in Thinc versus when to incorporate either PyTorch or TensorFlow or some of those other frameworks into the network as a component of the Thinc project rather than just doing it entirely without those frameworks.
So our goal is to avoid having in the long term models which have a strict dependency on PyTorch or TensorFlow as the core pipeline APIs in SpaCy, because I think that this does make things sort of operationally simpler for most SpaCy users. So the way that I see it is that PyTorch in particular is a really excellent compiler of these architectures, and it's able to really take very general, basically you can implement things in a very sort of neutral way without worrying about the performance details, and PyTorch will pretty much always do a pretty good job of that. And so it's a lot easier to get to, basically a good performance level without having to manage the specifics of the computation and in particular specifics of the device. But that said, if you take any specific architecture and you implement something in CUDA or C yourself, you can usually at least match what the performance that you would get from something like PyTorch. So the way that I would do it is that when I'm experimenting with something and I want to say try out a GRU, well, I might not have a GRU implementation in Thinc, and so I'll certainly just plug in PyTorches. And there's no performance penalty for doing that. There's no overhead in translating the tensors from QPy to PyTorch. It uses the DLPack formulation. When you have PyTorch, we have a thing that sets QPy's memory allocated via PyTorch as well, so you've only got one memory pool. So there's really no disadvantage of that. You just have to have PyTorch installed. So there'll be all sorts of architectures where it's either easier to implement it initially in PyTorch, or there's already PyTorch code for it where I would be using that directly, and then eventually, if we want to provide that to SpaCy users, or if I feel like I can do a little bit better than PyTorch in optimizing that specific architecture, I would switch that over to Thinc. The other thing is that sometimes you have these sort of high-level building blocks of models, and some of that composition is actually easier to do in Thinc by just thinking about them as different sort of functions that you plug together. So in particular, I'm used to the way of writing things in Thinc, and I find that that's something that I find kind of concise to define models and try different things out. But for different components, maybe there'll be something where it's easier to have a PyTorch wrapper around it. Now, in terms of users of SpaCy and users of Prodigy, almost always they'll be more familiar with PyTorch, and they'll want to work more directly in PyTorch, and they'll want to have that as especially initially as, they'll want to have that as the development framework, and then they can just use a thin wrapper from Thinc around it. And, over time, maybe they'll decide to do some other specific thing in Thinc rather than doing it in PyTorch directly. But the aim is to let people work with the frameworks that they want to work with. And I imagine that for most developers, they'll want to work with, PyTorch, and that's a pretty standard technology in machine learning.
So all of these tools that we've been talking about are open source, and they're something that you're working on as a core element of your business. And I'm curious what you have found to be some of the biggest challenges in terms of building and maintaining these tools to meet the needs of data scientists and machine learning engineers, and the approach that you're taking to making them sustainable.
So one thing that's definitely difficult about this is that the technologies are changing so quickly, both in terms of the research underneath it and also the software ecosystems around things. We have to strike the right balance between maintaining a good amount of backwards compatibility and stability for people, while also moving quickly enough to take advantage of new opportunities from technology and new integrations with things, and basically providing a better experience and improvements to data scientists. So I would say that that's definitely something that's challenging about this type of work, and to basically be pushing ourselves to deliver the best quality software that we can. Certainly there's this constant background thing of, the continuous integration systems are changing underneath us or something. So at some point we implement everything and get set up with, Travis Apvea and Circle CI, and then, Azure Pipelines comes out and we see that, that's a better option. So we migrate our things there, and different wheel formats and different build tools and things. So there's this sort of background level of, all of the, basically the boring problems of the technology stack around us, changing and improving, and different libraries and all of these things. So that's definitely something that occupies a surprising amount of time. It's just all of the rest of these like ecosystem things and interactions with, all of the other software that you wouldn't think of as sort of core parts of solving the problem, but it's definitely things that need to be done to keep delivering high quality software.
And then as far as the most interesting or impressive projects that you've seen, I'm curious what you have found to be notable and worth calling out, either things that your team is creating with the tools that you're building, or things that you have seen built with those tools that you're releasing.
So we're always really blown away by seeing all of the things that people are building with SpaCy, and that this is definitely something that's constantly increasing and improving. So we have a collection of these projects on the website called the SpaCy Universe. So two ones which I want to call out in particular are two models for two SpaCy pipelines for specific types of text. So one is Blackstone, which is a SpaCy pipeline for legal text processing, and another one is SpaCy, which is a SpaCy pipeline for biomedical text processing developed by the Allen AI Institute. Another project that I think is super cool is this information extraction system called Holmes, based on predicate logic. So that's something that I've always wanted to dig into a bit more. It was developed within a company and then, basically kindly open sourced. So it's really quite a substantial project that I think, is definitely cool. Another one which we developed internally that people might want to check out is we have this project called SenseToVec, where we train word vectors based on text that's been pre-processed with SpaCy. So noun phrases have been merged into one token, or entities have been merged into one token. And earlier this year, we ran SpaCy over all the text in Reddit. So this was, several billions of words from 2010 to 2020. And we used this to get the entities and basically make vectors. And then we pre-computed similarities for those vectors on the GPU so that there's, you can get pretty much instant nearest neighbor queries across all of these terms. So you can find similarities across entities and things, which is quite cool to play with.
And as a contributor and maintainer of all these projects, and as somebody who is running a business that relies on them, what have been some of the most interesting or unexpected or challenging lessons that you've learned over the past few years?
So one of the things that's, definitely important is the way that the projects are documented and communicated. So and, this also stems back to, initial design decisions as well, and, basically making sure that things are consistent in the projects and consistent in the libraries. And I think that this really makes things, sort of more useful and open to a wider audience. So this was something in particular that, improved a lot with my collaboration with Ines. So she's been really a driving force in getting the guides and level of explanation that we deliver, to basically a higher level. And I think that that's something that's really been setting apart some of our projects as well. And when we saw this in particular when we went back and did Thinc, that there were so many things where, we felt like we'd done this before, of setting up these libraries and setting up a tool in which people would find useful, and, ways of doing the documentation, things that people would need. So we've learned a lot from the types of questions that people have and the types of API design decisions that will, lead us into maintenance problems or be confusing to people. And we've been able to head off some of those things at the start with Thinc, which we've been pleased about. So those are all things which, I definitely think that we've learned as well. And also just the ways of setting up the testing and making sure that the code is well tested and testable to avoid some of these bugs in the first place.
And as you look to the future of the Explosion company and the projects that you're building there, what do you have planned and what are you most excited for?
So one of the things that we've been working on for a long time and we're excited to finally get out would be an extension to Prodigy called Prodigy Teams, which has more of a sort of team management interface and, it has a hosted component where you can allocate work to individual annotators, start and stop annotation tasks and things. So that's something that we've been working hard on. Because it has this, part of it's a more managed architecture and there's a more intricate web app behind it, it's taken us a little longer to develop. It's been going well and we're really excited to get that out to people. And yeah, that's, basically the main thing that we've got in the pipeline as well as having, getting SpaCy 3 out, which will make it much easier to use transformer models and really allow you to bring your own model and, basically make it easier to interact with those technologies of SpaCy.
Are there any aspects of your work at Explosion or on the SpaCy and Prodigy and Thinc tools that we didn't discuss yet, or anything else in the space of natural language processing and deep learning that we didn't discuss that you'd like to cover before we close out the show?
Yeah, so one of the things that's been different with Explosion since we last spoke is we've managed to grow a small but extremely effective team that we've been working with. So SpaCy's core maintainers now also include Sophie and Adrian. So we've got a team of now 4 people working on it full-time, and that's really been helpful. So in addition to myself and my co-founder Ines, and then we also have Sebastian Ramirez has joined the company. So we started working with him because we started using his open source library Fast API, which I think is a really great tool that any Python developer who needs to write REST APIs should check out. And so he's been working with some Prodigy teams, and as well as we've got another developer, Justin, who's in the US, who's working on teams as well. So yeah, we've now got a few extra developers working with this, and on the scale of things, it's still quite a small team, but we really feel quite blessed to be working with people who are very effective and work all quite independently. And, I feel like it's a very fun collaboration that we have with people.
Well, for anybody who wants to get in touch with you and follow along with the work that you're doing, I'll have you add your preferred contact information to the show notes. And with that, I'll move us into the picks. And this week, I'm going to choose the movie Onward that I watched recently with my family. It's a movie aimed at younger kids, but it's great for the whole family. Hilarious, really interesting storyline. Just had a great time watching that. So if you're looking for something to watch with the whole family, I'll definitely recommend it. And with that, I'll pass it to you, Matthew. Do you have any picks this week?
So outside of the, AI space, a lot of my time over the last few weeks has been spent following the coronavirus pandemic. So I'm sure by the time you listen to this, anything that I say will be different. But I guess just stay safe with that. And, in terms of picks for, things within the ecosystem or recommendations to make, one project that I think is really cool that people might check out is this library called Ray, which is developed by some people originally from lab at Berkeley. And I think it's a really cool way to, basically write distributed applications for machine learning in Python. So it's still quite young, but I think they've got a nice design, and it's something that, I think will continue to be popular and is one to check out.
Yeah, I'll definitely second that one. And the original creators of the library have also founded a company called Anyscale to try and accelerate the development of that framework and turn it into a viable business. So definitely something to keep an eye on there.
Mm-hmm.
Well, thank you very much for taking the time today to join me and share the work that you're doing at Explosion on all of your different projects. Definitely a lot of interesting tools that contribute a lot to the ecosystem. So I appreciate all of your time and effort on that front, and I hope you enjoy the rest of your day.
Thanks. You too.
Thank you for listening. Don't forget to check out our other show, the Data Engineering Podcast, at dataengineeringpodcast.com for the latest on modern data management. And visit the site at pythonpodcast.com to subscribe to the show, sign up for the mailing list, and read the show notes. And if you've learned something or tried out a project from the show, then tell us about it. Email hosts@podcastinit.com with your story. To help other people find the show, please leave a review on iTunes and tell your friends and coworkers.